My name is Maria Cedeno, and today I'm going to be talking to you about 3D printing and chemical/medical applications. So, what is 3D printing? 3D printing is a process of making a physical object from a three-dimensional digital model, typically by laying down many substantive thin layers of material. In other words, it brings a digital object into its physical form by adding layers by layers of material. 3D printing is no longer new. Chuck Hull, the Thomas Edison of 3D printing industry, introduced the first 3D printer in 1983, nearly 40 years ago. Since that time, 3D printing, otherwise known as additive manufacturing, has been used to create everything from shoes to airplane parts and even food. Although issues such as durability and speed have taken 3D printing from entering mainstream manufacturing, the industry is making tremendous advancements. For example, 3D printing is becoming increasingly prevalent in modern chemistry laboratories. This technology provides chemists with the ability to design, prototype, and print functional devices that integrate catalytic and analytic functionalities, and even to print standards laboratory hardware and teaching aids. Although access to 3D printers have increased considerably, some design principles and material considerations need to be weighed before employing such technology in chemistry laboratories. In addition, a certain level of experience needs to be acquired in order to use computer-aided design, printing softwares, and the specialist hardware is associated with the higher-end instrumentations. Nonetheless, the recent progress in this field is encouraging, with these printing technologies offering many advantages over traditional production methods. Since the early 2000s, when the first research paper applying this technique began to emerge, the uptake by the chemists community have been both diverse and extraordinary. 3D printers are used to manufacture a variety of medical devices, such as instrumentation, external prosthetics, and implants, including those with complex geometry or features that match a patient's unique anatomy. This technology could be used to replace human organ transplants, speed up surgical procedures, produce cheaper versions of required surgical tools, and improve those lives of people needed to prosthesize limbs. Scientists are researching how to use the 3D printing process to manufacture living organs such as hearts or liver, but this research is early stages of development. This method of 3D printing has been applied in medicine as well since the early 2000s, when the technology was first used to make dental implants and custom prosthetics. Since then, the medical application for 3D printing have been evolved considerably. Recently published reviews describes that the use of 3D printing to produce bones, ears, skeletons, jawbone, eyeglasses, stem cells, cell cultures, blood vessels, vascular networks, tissue, and organs, as well as novel dosage forms and drug delivery devices. I personally believe that the use of 3D printing in the medical field is such an innovative move, as well as a huge step into the future of medicine, since we know that tissue or organ failures due to aging, disease, accidents, and even birth defects are currently treated by transplants from living or deceased organs. However, there's a chronic storage of human organs available for transplants. In 2009, 155 patients in the United States were waiting for an organ. Only 18% of them received an organ transplant, and around 9,000 of them die while waiting for one. As of early of 2014, approximately 120,000 people in the US were waiting an organ transplant. Organ transplant surgeries and follow-ups, it's as well expensive, costing over more than $300 billion. An additional problem as well into this is that organ transplantation involves the often difficulty task of finding a donor whose tissue match perfectly with the patient. This problem could likely be eliminated by using cells taken from the organ transplant patient's own body to build a replacement organ. This would minimize the risk of tissue rejection as well as the need of the lifelong insuperable. And last but not least, 3D printers are being used to enrich STEM education through a variety of learning techniques and experience. Reports of 3D printing models for improved visualization of chemical phenomena as well as educational of use of 3D printing laboratories devices are rapidly increasing.